Hi everyone, my name is Sabrena and I am a student in ITS 420 class with Dr. Bab. Um, this is my final presentation recording for the class, so thank you so much for listening in. Um, so I will discuss all of the things that I have personally learned throughout the course, which I felt were valuable information to me. In week one, we learned about how networks, I personally did some research on networks and how they're straining under the weight of users and how businesses now have less control over their data. So one of the biggest challenges currently facing mobile operators is the increasing demand for capacity. Data-intensive devices are driving up wireless throughput requirements at an alarming rate, and that puts strain on networks that don't have the ability to cope with the increase in data traffic. It is essential to find the most flexible and cost-effective infrastructure for the next generation devices. In urban areas, it is difficult to keep pace with network growth for capacity demands at work, home, and during leisure. The BYOD, also known as Bring Your Own Device trend, is threatening enterprise networks due to the high volume of users all being in one place. This increase in data traffic caused by mobile devices will put even greater pressure on the network. There are several factors to consider when seeking a solution for in-building coverage and capacity. The network infrastructure must be simple and cost-effective to deploy. The infrastructure should easily scale to cover new areas, support higher capacity, and adapt to future implementations of wireless standards such as LTE Advanced. The solution should support multiple mobile operator devices. Furthermore, businesses can't just rely on Wi-Fi networks to take in increasing wireless demand. The reason for this is because there are several different types of users, and Wi-Fi administrators will not be able to serve them all. For example, security concerns prohibit visitors as well as contractors accessing the Wi-Fi networks, and even employees, since they may not be able to get the bandwidth they need to in a congested Wi-Fi network. During week two, we learned about how two devices can connect, how two wireless devices can be connected. One method of doing so is by setting up an ad hoc network. This is a network created when two wireless devices connect to each other directly. Wi-Fi Direct is also a solution for peer-to-peer network, which can be used to connect two or more devices without having any WAP or router, even if they are from different manufacturers. Another method is Bluetooth. With Bluetooth, you can connect a keyboard and a pair of headphones to your iPhone at the same time. You can also connect two wireless laptops using a crossover cable. Another option is to share computers or as servers. Advantage, um, uh, the advantage to this is that the drive icons of the other computer will show up on the desktop as volumes. During week three, um, uh, I learned about the security problems within wireless connections. So wireless connection is the most vulnerable element of the IT infrastructures. As soon as employees are allowed into the wireless network with their own personal devices, the entire system becomes vulnerable to hacking and viruses. Wireless networks can never be as safe as a wired network. If a company deals with confidential and personal information, a wireless network would be a massive liability. Although wireless technology has improved over the years, it is still not as fast as a wired connection on a local network. When connecting resources on your local network, such as file shares, this could be noticed from a performance perspective. During week four, I learned about WiMAX. So WiMAX stands for Worldwide Interoperability of Microwave Access. It is a wireless industry coalition dedicated to the advancement of IEEE 802.16 standards for broadband wireless access networks. WiMAX supports mobile, nomadic, and fixed wireless applications. A mobile user is someone in transit, such as a commuter in a train. A nomadic user is someone who connects on a portable device but does so while stationary. For example, connecting to an office network from a hotel room and then again from a coffee shop. Fixed wireless refers to a wireless connectivity among non-mobile devices in homes or businesses. During week 5, I learned about routers and switches and the differences and similarities among the two. So routers and switches are both computer networking devices which allow one or more computers to be connected to other computers, network devices, or other networks. The function of a router, switch, and hubs are all different. A router directs data in a network. A router passes data between home computers, between computers, and the modem. A switch functions to allow to connect multiple devices and ports to be managed, and VLAN can create security. There are several predictions for what sort of technology will replace switches, just as switches replaced hubs. SDN, also known as software-defined networking, is a place where it can readily replace traditional routing and switching devices. Experts in the field predict that there will be adoption of better virtualized solutions and software-defined methods, which will improve deployment and access. So during week 6, we discussed what would be the next new technology 5 years from now that'll be really, really mind-blowing and awesome. So 10 years ago, smartphones didn't exist. One of the biggest changes in wireless technology today from 5 years ago is the wide usage of applications. Apple released the App Store after its first iPhone was released to the market. Apple's iPhone sales flourished once users were free to choose from the thousands of different independently developed mobile optimized programs. 5 years later, Apple's devices have downloaded nearly 50 billion apps, resulting in more than $9 billion in payments to app developers. Today, approximately 2.5 billion applications are downloaded per month. This application usage phenomenon has created more than 460,000 high-paying jobs. For example, Facebook's users download 20 million apps every day, leading to the sale of at least $1.7 billion in virtual goods every year. In the near future, self-driving cars are projected to make significant progress. According to Forbes, 10 million self-driving cars will hit the road by 2020. With the widespread usage of Uber, one can safely conclude that people want fast, easy, and affordable rides. Self-driving cars fulfill this need. Some experts believe that given the recent improvements of safety, it will only be a matter of time before the manual driving of cars is outlawed, outside of hobby clubs and racetracks. So case study 2 was a really great learning opportunity for me. I discussed Cisco's upgrade from IPv4 to IPv6. So as many of you know, Cisco is the largest networking company in the world and the worldwide leader in networking for the internet. Cisco develops, manufactures, and sells networking hardware and telecommunications equipment. Cisco was founded in 1984 by two Stanford computer scientists, Leonard Bosack and Sandy Lerner, to connect different types of computer systems. They developed the concept of local area network, also known as LAN, which is utilized to connect geographically separate computers over a router system. According to Cisco's website, 85% of internet traffic travels across Cisco systems. The utilization of IPv4 is no longer feasible because the internet is starting to run out of IPv4 addresses with the rapid usage of new devices connected to the internet every year. IPv4 makes it possible for devices to connect to the internet. IPv4 functions like IPv6 since both provide the unique numerical IP addresses necessary for internet-enabled devices to communicate. IPv4 address is 32 bits and IPv6 address is 128 bits, which means that IPv6 can provide significantly more addresses. So IPv6 provides 2 to the 32 addresses, and then IPv6 provides 2 to the 128 addresses. So that's a lot of addresses. So IPv6 provides 340 decillion addresses, which means that it can support potentially unlimited amount of devices. Despite these significant differences, only a small portion of the internet has switched to IPv6. In order to transition into IPv6 device address, software and router will have to be changed to support more advanced network, which requires a lot of time and money. Although most operating systems support IPv6, many routers and servers do not support it, making a connection between a devices with an IPv6 address to a router or server that only supports IPv4 impossible. In summary, IPv6 is still in its early stages, and most experts are not sure when the full transition will be completed. So basically, Cisco is attempting to gradually make the switch to IPv6 addresses to fulfill the recommendations of American Registry for Internet Numbers. Cisco has adopted dual-stick approach to simultaneously support IPv4 and IPv6 traffic. So Cisco has decided to make the switch because the proliferation of mobile devices are driving the business case to its internal IPv6 adoption. Cisco realizes the migration is vital and time sensitive, especially because IPv4 address space is approaching depletion. Furthermore, Cisco needs IPv6 infrastructure to develop and test IPv6 compliant solution in real-world environment for customers planning their own migration. This is an ambitious feat for Cisco because it affects network devices in 400 Cisco offices in 90 countries, and more than 180,000 people connect to Cisco corporate networking, including 70,000 employees, 20,000 channel partners, and 100 plus application service providers, as well as approximately 200 development partners. To successfully transition into an IPv6 system, Cisco needed to follow a set of protocols. Cisco needed to bring together a cross-functional program team, acquire IPv6 space, and decide which IPv6 approaches to use. Tunneling, proxy servers, and dual stack. Following this, it had to perform a readiness assessment, including network devices as well as Cisco iOS softwares on those devices, as well as work with service provider partners to support IPv6 with service level agreements equivalent to the existing IPv4 SLAs. Lastly, Cisco had to develop an IPv6 version of Cisco public website. The specific steps Cisco took to migrate IPv6 were project planning, acquire an IPv6 address space, select an approach to IPv6 integration, reference architecture and IPv6 internet presence. Furthermore, it had to conduct a readiness assessment, partner with service providers for IPv6 services, and create IPv6 internet presence. In the project planning phase, Cisco did not want to risk existing IPv4 services and applications, such as Cisco.com and internal corporate network. Cisco also wanted to make sure it did not compromise corporate security layout. Cisco wanted to make sure to reuse existing infrastructure, capabilities, content, and application environments whenever possible. To acquire IPv6 address space, Cisco enabled its DNS infrastructure to advertise AAAA records so that domain names can be resolved to IPv6 addresses. Um, as I mentioned earlier in the case study, Cisco utilized dual stack approaches to allow devices to support IPv4 and IPv6 simultaneously. Cisco implemented an end-to-end IPv6 infrastructure as a reference for public sector customers to satisfy their compliance requirements. Cisco also tested for readiness by utilizing Cisco network optimization, which identified both hardware and software gaps. As the hardware did not support IPv6, if the hardware did not support IPv6, Cisco replaced the hardware through its fleet management program. If the software was not compliant to IPv6, Cisco upgraded it. Following this, Cisco partnered with service providers to make sure IPv6 based services Cisco received were comparable to the IPv4 based network services at the time. To create IPv6 internet presence, Cisco built a parallel IPv6 environment that became active in 2010 and was available to users connecting from the IPv6 network-enabled host. Cisco made additional web services IPv6 accessible by utilizing proxy solution. To complete the IPv6 internet presence page, Cisco made sure that IPv6 clients automatically connected to the newer IPv6 infrastructure while IPv6 clients connected to the IPv4 infrastructure. Because of this project, Cisco learned to engage early with IT teams outside of the core networking team, consider the implication of IPv6 addresses with external parties, account for lead time from vendors and project plans, and realize that end device operating systems behave differently with IPv6. So I'm kind of out of time here. But basically, later I go into the advantages and disadvantages of Cisco's transition to IPv6. So an advantage is that there was a security enhancement because any attacker attempting to hack Cisco's network would have to scan the IPv6 address space, which is significantly larger than the IPv4 address space, to find Cisco's network. A drawback is that the encapsulating security payload doesn't support data encryption. Furthermore, Microsoft IPv6 doesn't support Internet Key Exchange to negotiate security associations. So this makes it so that one cannot configure IPv6 security policies through group policy. So I got this Cisco case study from the Cisco website itself, and then all the other information for the discussion boards. I did a lot of research as well, and I got them from other sources, which I cited throughout the weeks. But basically, I'm so sorry for the lengthy presentation here. But I learned a lot in this class, especially I really enjoyed learning how it applies to real world, and we learned beyond just the theories of things. So thank you so much for your time, and thank you for listening in. I really appreciate it. Have a wonderful day and a great end of the semester.